Hello everyone, Sim here. Today we're going to go through a question from the HSC Year 11 Further Trig topic. Before we get started, I recommend that you pause the video and give the question a go on your own. Did you get stuck? If so, maybe knowing which formulae you need for this question will help. If you're unfamiliar with any of these formulae, comment below and I'll do a video introducing and explaining them. Now pause the video and give the question another go. Still stuck? No worries. Let's go through it beginning to end. So the question starts off with prove. That means we're going to start off by saying the left-hand side equals, and by the end, hopefully we'll have something which equals the right-hand side. So tan 2a cotA minus tan A. At this point, we notice that there's a little caveat at the end, provided cotA is not equal to tan A, because then obviously this expression would resolve to be 0 instead of 2, so it wouldn't work. So let's keep going. Now, tan 2A, we use our first formula for the double angle formula. So we have this equals 2 tan A over 1 minus tan squared A cot A minus tan A. Good. Next step, I'm going to use the second lot of formulae to remove all our tans from the equation and just have everything in terms of sines and causes. So we have 2 sine A over cos A over 1 minus sine squared A over cos squared A. Here we have cos A over sine A minus sine A over cos A. Now, I've got lots of fractions within fractions, which we don't want, so let's go through getting rid of them. To get rid of them, we need to multiply by some interesting representations of 1. This part here, I'm going to times by cos squared A over cos squared A. So here we have equals, the top row, the numerator, becomes 2 sine A cos A, and the denominator becomes cos squared A minus sine squared A. Then we have our brackets here still, and for these brackets, I want to get a common denominator. So given that one fraction has a denominator of sine A, and the other fraction has a denominator of cos A, the common denominator I'm looking for is sine A cos A. So this fraction, I'm going to multiply by cos A over cos A to get that denominator. And this fraction, I'm going to multiply by, I need to multiply the denominator by sine A to get that common denominator. So I have to multiply the numerator also by sine A to not change the value of the fraction. This means that we have cos squared A minus sine squared A on the top. Now things are starting to look a lot simpler. We have sine A cos A cancelling out there, and we have cos squared A minus sine squared A cancelling out there, which leaves us with our 2, which equals the right-hand side that we were looking for. And as such, we have our proof. I hope you found this video useful. Comment below with any questions or topics you'd like me to see me cover.